Okay, so today we're going to talk about solving equations with variables on both sides. So this is going to have a lot of the same steps as what you did in 2B, but it is going to be slightly different just because you now have those variables on both sides. So it's really just one more additional step. So our steps in a general sense are, first thing we have to do is move the variables to one side. We just want one variable on one side. Then our second one, we want to isolate the variable. So what I mean by that is we want to move all the regular numbers and other garbage to the other side. And that way you just have your variable alone by itself, whether it's 6x or, x over 4 or whatever it is, whatever term has that variable in it, we want that term to be isolated by itself. And then the last step is simplify. We do the opposite of our operations to get that variable completely by itself, so we're left with x equals 3 or x equals 1/2 or whatever the answer may be, but we want just the variable equals number for our final step when we're all finished. So let's go through a couple examples of this. Example number 1, we have 4 minus 7f equals f minus 12. So our first step, we want to move the variable to one side of the equation. So for me, I want to move the 7f over to the right-hand side. And why I want to do this is because I don't like dealing with negatives. And I know since it's minus 7f, I can get rid of that by adding. So if I add 7f to negative 7f, I can just cross it out, it's gone. And then I also have to add 7f to the right-hand side then. So that leaves me with 8f minus 12 on the right-hand side, and then 4 on the left-hand side. So that's the end of my first step. Now, my second step, I want to isolate the variable. So I want to get that term with the 8f all by itself. And in order for me to do that, I need to get rid of that minus 12. And in order to get rid of the minus 12, I have to add 12. So we're doing the opposite of whatever operation is shown. So since subtraction is shown, we're adding. So I'm going to add 12 to minus 12, which means I can cross it out. But then I have to do it on the other side to keep the equation balanced. So I add 12, which leaves me with 16 equals 8f. Okay, so now I have the term on the right-hand side with the f completely isolated. So my second step is now done. So my second step in blue is finished. Now we move on to our third step, which is just simplification. So we are going to, in that term with the 8f, so it's 8 times f, and we want just the f by itself. And since it's 8 times f, what I have to do is I have to divide by 8 to get rid of that times 8. So I'm dividing by 8 on both sides, which 8 divided by 8 is 1. So we can just cross that out and just leave it as f. And then 16 divided by 8 would be 2. So now we're left with 2 equals f, which is our answer. That's what we're trying to get. We're trying to get just the variable equals something else. And in this case, our variable f equals 2. Now, you can leave it like this. Personally, I'm weird and I like the variable alone on the left-hand side. So I'm just going to flip it and make it say f equals 2. That step's completely optional, but I'm kind of weird and I like it visually to look that way. So I'm going to flip mine because, like I said, I'm weird and I'm picky that way. All right, so our second example, we're going to do the same thing again with a new equation. So first step, as always, move the variable to one side. So I'm going to move the 3g to the left. Reason being, 5's bigger, so I want to keep that variable positive. You could move the 5g to the right-hand side as well. It's totally up to you. But for this example, I'm going to move the 3g to the left. So it's just a positive 3g sitting there. In order to get rid of that, I need to subtract 3g. So I'm going to subtract 3g, cross that out, subtract 3g from the other side to keep my equation nice and balanced. So I'm going to be left with 2g minus 14 equals nothing. So I have the variable on one side, but there's some other stuff there too. So I'm going to go into my second step and I'm going to isolate that term with the variable. I'm going to leave that 2g all by itself on the left-hand side. In order to do that, I need to get rid of the minus 14. So in order to get rid of the minus 14, I'm going to do the opposite operation. So they're subtracting. The opposite of subtraction is adding. So I'm going to add 14, which gets rid of that. And then 0 plus 14 on this side, which leaves me with 2g equals 14. Now, for my third and final step, I want to get that g all by itself. And right now, there's a 2 being multiplied onto it. So instead of it being 2g, I want it to just be g. In order to do that, I need to divide by 2. So I'm going to divide by 2 on both sides. 2 divided by 2 is 1, so we can cross that out. So I'm left with g equals 7. My variable's on the left side, so I'm all happy. I don't have to flip it this time. All right? Now our third and final example, we're going to follow the same steps once again. So I want to get my variable isolated on one side. Once again, so we have 7x plus 12 equals 6 minus 2x. So right away I see minus 2x. I want to get that on the left-hand side. So in order to get rid of the minus 2x, I'm going to add 2x to both sides. Adding it to both sides to keep the equation balanced. So we're left with 9x plus 12 equals 6. And then our next step, we have to get that term with the variable by itself. So in order to do that, I need to get rid of that plus 12. To get rid of the plus 12, I'm going to need to minus 12 because subtraction is the opposite of addition. So to get rid of the plus 12, I need to minus 12. I'm going to do that from both sides. So now I am left with 9x equals negative 6. Okay, now we move into our final step because we have that term with the variable isolated. Now we need to divide to get rid of that. So I'm left with, so I have 9 times x equals negative 6. So in order to get rid of that 9 times the variable, I need to divide by 9. And I'm going to do that to both sides. So now I'm left with x equals negative 6 over 9. Now, we do have the variable completely isolated. We know x equals negative 6 over 9. Personally, I'm going to choose to reduce this because it needs to be reduced to be in simplest form, and that's the way I want to do it. So I'm going to divide both the top and bottom by 3, and I'm left with negative 2 over 3. So my final answer is going to be x equals negative 2/3. Okay.